Hello and welcome back to the channel, or welcome to the channel if you're new. Mixed Concepts here. So in this video I'll be solving the integral of x over x squared minus 25 dx. Now it's not a hard integral, but there are apparently three integration techniques you can use to solve this, and I'm going to go through all three of them. Alright, so first I'll rewrite the integral because the text may not be very clear. So this is basically the integral I am going to be evaluating. X divided by x squared minus 25 dx. Okay, well first, just going to do the typical U-sub because that's by far the easiest method. So going to make u equals x squared minus 25, so that's the denominator, and du will be 2x dx. Since only x dx is on the top, so just gonna divide both sides by 2. So which means it'll be 1/2 du equals x times dx. So now if I write this in terms of u, it would basically be the integral of 1 over 2u du, which can also be written as 1/2 times the integral of 1 over u du, and the integral of 1 over u is just ln of u, so basically it's going to be 1/2 times ln of u. I'm just going to write everything in absolute values for good measure. And basically plug in x squared minus 25 for u. So the answer at the end is 1/2 times ln absolute value of x squared minus 25. And don't forget, always put the plus c whenever you're evaluating an indefinite integral. Always remember plus c. Alright, that's u-sub done. U-sub's easy. However, you can do this using trig sub. I'm gonna scroll up because there's some space. Alright, so if I want to use trig sub, well, how does that work? So I'm just gonna rewrite the integral again. So it's x squared over x, so x divided by x squared minus 25 dx. That's the integral. Now to solve this using trig sub, you're going to have to know three. I think there's 3 ways you can do this. Because it's in the form, the denominator is in the form of x squared minus a squared. I think it's recommended to use secant theta. So you want to convert that into secant theta. Yeah. As I said in my previous integral videos or calculus videos, I'm not really explaining. I'm just walking through the problems. Yeah, it's really just a problem walkthrough. I'm not really explaining. But if it really is helping you, that's great. So now that we figured out that we're going to have to use secant theta, so a squared is 25, so a is 5. So basically, we're going to substitute x as 5 times secant theta. Yeah, bear with me, my writing is no good, I know that, and it's not going to be easy. The derivative of secant theta is secant theta times tangent theta, d theta. So dx in this case will be 5 times secant theta tangent theta d theta. So that is the derivative of 5 secant theta. Okay, well, I'm also going to draw a triangle here just to help out what is going on here. Yeah, that's a terrible triangle. Let me try to see if I can draw that any better. Well, it's very unlikely, but okay, that's not bad. So we know what secant is, right? Secant is hypotenuse over adjacent, because cosine is adjacent over hypotenuse. That's one thing gotta remember. Yeah. If you're gonna use trig sub, you're gonna have to remember all the trig identities and rules. So, first, I'm just gonna write secant theta equals x over 5, and that would actually help out pretty well. So this diagonal line is a hypotenuse, so that is going to be x adjacent right here, this is adjacent, that will be 5. I just wanted to show where it is. And the opposite side, the vertical line, it's going to be x, the square root of x squared minus 25. And how do I know that? Well, if you remember the Pythagoras theorem, a squared plus b squared equals c squared, c squared is basically x squared, and this is a squared, so 5 squared plus b squared equals x squared. So yeah, you just put the 5 squared, you shift it to the right side, so b squared equals x squared minus 25, and then the square root of b is the square root of x squared minus 25. That's how I got it. Yeah. Okay, now it's time to substitute all the x terms and dx terms with the theta terms. So the integral will now look like 5 secant theta. Also, because dx is in the numerator, well, I'm going to multiply dx, which is 5 secant theta tangent theta d theta. And then in the denominator, well, x squared is just going to be 5 secant theta squared. And to save some time, I'm just going to evaluate it right now. So 5 squared is 25, and secant squared is really just going to be written this way. So secant squared theta, secant theta squared, minus 25. Okay. Well, what I'm going to do is in the denominator, I am going to take out the 25 because it's a common term in both terms. The point is 25 is common in both terms, so that's what I'm going to factor out. Well, the numerator stays the same, except I'm just going to multiply both the 5s to make it a bit easier. Yeah, of course, the writing is going to be a nightmare. Also, I can just multiply it out, so basically it's going to be secant squared theta times tangent theta d theta. Please ignore my writing, I know it's not good. Alright, now here's another, this is a side note. Well, this is a trig identity you need to know. That's the best way, and probably the only way you could really solve this problem. Secant theta squared minus 1 is actually equal to tangent theta squared. Exactly. This is an identity that needs to be known. Alright, now that we know the data, now that we know the identity, that's what I'm gonna substitute in for secant theta squared minus 1, tangent theta squared. And I can also eliminate the 25s from the numerator and the denominator. I'm just gonna erase it because I was just trying to show what I'm gonna do next. Alright, so now we just have the integral of secant theta squared times tangent theta over tangent theta squared d theta. Now, notice something else. There are two tangent thetas in the bottom, one on the top. So I'm gonna eliminate the one on the top and eliminate this. Just one of them. So that's the next step. So all that is left will be the integral of secant squared theta d theta over tangent theta. Yeah. Now, this is another beautiful part of this integral, because it's just a simple u sub. U equals tangent theta, that's what you want to make u equal to, and then du, the derivative of tangent theta, is equal to secant theta squared d theta. That's the beauty of this. So at the end, all that is left is it's going to be 1 over u du, which is literally ln of u. And what's u? Tangent theta. I know I'm skipping steps, but hopefully you understand what I'm trying to do. So I am trying to draw a straight line for the absolute value. Okay, that's a little better. So it's going to be ln of tangent theta plus c. Well, are we done yet? No. Now it's time to convert the theta back to x. So what is tangent theta? Opposite over adjacent. And that is why I drew the triangle, because I wanted to figure out what the opposite and adjacent are. Now the adjacent was already figured out thanks to substituting x as phi secant theta, but I had to calculate the opposite, and I did. So at the end, this is the answer to the integral. Using trig sub, the answer is ln of, I'm just writing an absolute value. I don't think it has to be written, but it's always a good idea to write it in absolute value. So it's ln, okay, in the numerator is the square root of x squared minus 25 divided by 5 plus c. That's it. That's trig sub done. Yes, it's definitely a longer process, but that's another way it can be done. So that's the second method done. Well, what is a third technique that I could use to solve this problem? Partial fraction decomposition. That is the third technique that can be used. I'm going to scroll down to solve the problem now. Don't know if I have enough space, but I'm going to make it work. So I'm just going to rewrite the integral for good measures. So it's the integral of x divided by x squared minus 25 times dx. Well, if you've noticed, x squared minus 25, it's in the form of a squared minus b squared. Exactly. And the square root of 25 is 5. So it's not that hard to write it down. Well, I'll first show what I mean. So in other words, this is also the denominator could also be written as x plus 5 times x minus 5, right? Yeah. Yep. So that's how the denominator can be written as. It just doesn't have to be written out as x squared minus 25, just x plus 5 times x minus 5. Alright, now to write it in partial fraction decomposition form. So basically now this is gonna be a lot of side work to be done. So here is how it's written. So you can substitute any alphabet you want. Don't substitute an X though. I'm just gonna use A and B because it makes things a bit easier. So basically A divided by X plus 5 plus B divided by X minus 5. Make that equal to the integral, essentially. So X divided by X squared minus 25. Yeah, I'm just gonna rewrite the 2. Alright, next you want to multiply every term here by the denominator x squared minus 25. And what we get when I scroll to the right is a, just make sure what I'm doing. So what we get is a times x minus 5. Dear me, that is horrible writing. I'm sorry. Plus b times x plus 5, and that equals x because the denominator and the numerator cancel out. Alright, now I'm just going to substitute 5 for x. So I'm going to make x equals 5. And if I do that, in that case, it will be a times 0, because 5 minus 5 is 0, plus b times 10, and that equals 5. Okay. Alright, based on this, 0 times a is 0. And it's basically 10b equals 5. So b equals 1/2. Yeah. Okay. Now, if I were to plug in x equals -5, then it's kind of the same thing, except you would see -10a plus 0b equals -5. I'm skipping some steps, but it's basic math at the moment, or at least it should be basic math if you're watching this video and understanding anything I'm saying, hopefully. So a equals -5 over -10, which is just 1/2 as well. Alright, so a equals 1/2, b equals 1/2. So at this point, what we are integrating will be one-half divided by x plus 5 plus 1/2 x minus 5, all that dx. Now, another rule in integration. If there is a plus in a full integral, you can actually divide it up into 2 separate integrals. And what I mean is, I'm going to show it right now. Also, remember, when there's a constant in the numerator, you just put it outside, so you're basically multiplying the constant by the integral. So it's 1/2 times the integral of 1 over x plus 5 dx. And now this is what I mean when I am separating the integrals. Plus 1/2 times the integral of 1 divided by x minus 5 dx. Okay, now it's just a simple U-sub that needs to be done. Make U equals x plus 5, du equals dx, and that will be the same exact thing for when U equals x minus 5. I'm not going to write that down. So at the end, all there is 1/2 over 1/2 times du over u plus 1/2 times du over u. Well, it may look the exact same, but please keep in mind that the u is actually different in both integrals. In the first integral, I put u as x plus 5, and in the second integral, u is x minus 5. I'm going to make the distinction right now. Now we know that the integral of 1 over u is ln of u, and u is x plus 5 or x minus 5. So I'm just going to plug it in. So the answer is 1/2 times ln of x plus 5. Putting in an absolute value for good measure, plus 1/2 times ln absolute value of x minus 5. And don't forget, at the end, always put the plus c when evaluating an indefinite integral. And that is it. I have solved this integral using 3 different integration techniques. I first solved it using regular U-sub, and then the second method I used is on top here, where I solved it using Trig sub. And then the third technique was at the bottom, where I solved it using partial fraction decomposition. I know that the work here of the U-sub and the partial fraction decomposition looks like it's a continuation, but I promise you it's not. But if you really think it is, then I don't blame you, because yeah, I did not make a good distinction of separating the work. But there it is. I'm just gonna box all the answers for good measure. So these are the 3 answers you can get when you use 3 different methods. By the way, they all technically are the same answers. So any method you use is correct. Now, why did I do this? I'm not really sure, just for fun. Well, a fun fact, by the way, I actually had a test 2 or 3 years ago when I took calculus as a college student, and I had to do the same thing. There was an integral like this. I had to solve it using 3 different integration techniques. I managed to get the question right, so I did it here as well, showing it to YouTube. Yeah, but anyway, that'll be the end of this video. If you found it helpful in any way, that's fantastic, and please do leave a like if you did. If you didn't find it helpful as well, I would really appreciate if you liked the video and share the video. And please do subscribe to the channel for more content. And until the next video, bye.